Okay, are you ready? Okay, great. Hi, thanks everybody for coming. I'm Susan Doniger. I'm one of the facilitators of this free lecture series, which is a partnership between the Humboldt County Historical Society, the Clark Museum, and the Humboldt County Library. Thank you for coming. Oh, this is for late. This is for late.
That's what we're talking
this
about.
is, sorry. Did you want me to repeat?
Yeah.
Go ahead, yeah.
Okay, thanks for coming, everyone. I'm Susan Doniger. I'm one of the co-facilitators of this free lecture series, which is a partnership between the Humboldt County Historical Society, the Clark Museum, and the Humboldt County Library. Thank you all for coming. Today, we have a really wonderful treat for you. But before I get started, let me thank our sponsors, Carl Johnson's and the Cutting Edge Salon. So today we have two folks who have actually flown up from Santa Rosa. Our presenter is Andy Werback. Andy is a retired software engineer with a passion for naval World War II history. Today he's going to talk to us about the really amazing innovation that was the Advanced Base Sectional Dock, ABSD, and it reflects in our own dry docks operation at the Chicago Ridge and Iron that was here operating in Eureka during the wartime. Andy is going to talk about the ABSD's revolutionized naval operations, their self-sustaining design, their rapid deployment capabilities, and the critical role they played in servicing damaged ships near battle zones. So Andy's background is in electrical engineering, and he has firsthand experience as a shipkeeper on the SS Jeremiah O'Brien. So thank you. And also flying up with Andy is Bill Turner, who's a local Eureka, and a lot of you know Andy and his, Bill, and his relatives actually, he told me, worked at Chicago Bridge and Iron. So I'm very excited to have you both and get to know all about the sectional base. So with that, thank you, Andy.
Okay, I've got a microphone right here.
Okay.
Okay. Thank you, Susan, and welcome, and thanks for coming, and please feel free to ask any questions. I know there's a lot of information here that you guys have come across, and really glad to hear about that. So I was working on what is an advanced base sectional dock, just because it was mentioned a couple times in naval history, the logistics of the Navy in World War II in the South Pacific, and it kind of like raised a whole bunch of questions like, what is it, and how did it work? You know, you can go on a warship and get a tour. You can go on the Missouri or a battleship and get a tour, or you can go on the Hornet and get a tour. But you know, what's a sectional dock and what's a floating sectional dock? So try to explain some of that here. Yeah, it works. Okay, so just to preface that, World War II, 1945 or 41 to 45 Pacific Ocean. And Susan mentioned the ships are thousands of miles away. Pearl Harbor has happened, December 7th, 1941. And you know, things are really happening down in the South Pacific. The Japanese are taking over. They're in the mandated islands. They are expanding into the southwestern Pacific, you know, heading towards Burma and India. And we need to get a Navy down there and fast and be able to support it. So how best to do that? Floating dry docks and logistics are not cheap. They're just as expensive as the warships and everything else that goes along with them, all of the training, aircraft, ships, everything like that. What do we do? How best to support the fleet? Fortunately, we had the capability of developing facilities to do the things we needed to do, including building ships, airplanes, and dry docks. So this was the first dry dock assembled, ABSD-1, called the Artisan, in Espiritu Santo, September 1944. It had been there not quite a year, and servicing the USS California, a large battleship, which is the only battleship built on the west coast of California at Mare Island, 1931. And it had been hit by the Tennessee in a collision when their Syrian engine failed. And they got a pretty good clip in the bow. So having a floating dry dock right there where it was needed was really kind of nice. So they put the California in there, patched it up within 2 weeks and got it back in action, as opposed to several months going back to Pearl Harbor or Puget Sound Bremerton Naval Shipyard. So saved a lot of time, but it really was a huge effort to get these built and manned and down to the South Pacific where they were needed. The other part of the problem was we were building large battleships. They had not gotten there yet, but they were huge. They were twice as big, almost twice as big as the battleships we currently had. They had 16-inch guns. They were almost 900 feet long, and they're just, very wide, very heavy. We did not have any dry docks anywhere except on the mainland that could take a ship like that. And if a ship was really badly damaged and needed a dry dock, you needed to have a dry dock within, a couple days sailing. So aircraft carriers weren't as big, but they were just about as long and also nearly as wide. They drew a lot of water, so it took a really big dry dock to take one of these ships. So right around the beginning of this January 1942, just a month or so after, we'll talk more about that later, but things started happening very, very quickly. They dusted off plans, they updated things, they looked at a design that could take the largest ships, 10,000 tons per section was needed, and put in 10 sections together, you could get enough to hold an Iowa-class battleship. But the problem with a normal floating dry dock was it was too big to be towed to the South Pacific. So they broke it up into these 10 sections, and what we have here on display are the examples of the first 2 dry docks built in 10 sections, each little over 900 feet long, that could take the Iowa-class battleships. And these were huge. We have, for instance, a couple of acres at home. It's 600 feet by 200 feet. This is twice as that big. So it's as big as your front yard plus your neighbor's front yards, and a lot more than that. They're huge. So they were built as sections. Some of them were built here in Eureka. They could lift each section to 10,000 tons, so almost 90,000 tons for the whole floating dry dock. They took a lot of water in order to sink down because those pontoons are 28 feet high from the bottom of the pontoon to the deck of the pontoon. That's like way over the size of this building. It's huge, just incredible. And it was all done here. So here we have the ABSD-1. You can see that there's a nice resort town on shore there. Not really. This is Espiritu Santo. There's nothing there other than some plantations. So when you went ashore for a beer and some softball, what you got was the Navy brought some beer and the Navy brought a softball. Then you went back on board the ship for the next 2 or 3 weeks. Excuse me. Quick break here. So you can see, here we've positioned the keel blocks. These are what the ship sits on, and there are quite a lot of them. They're kind of heavy. They weigh about 2 tons apiece, and they're about 6 feet high, so you can get underneath the ship when it's on the keel blocks. That all goes down unsubmerged underwater when you let the water into the ballast tanks. Excuse me again. The cruiser then sails into it very slowly under total control, being winched in with capstans. And once it's fully unsecured, you pump all the water out, raise the ship out of the sea, and do whatever required work is done, patching holes or surfacing the bottom, straightening propeller shafts, whatever, and do the reverse to put the ship back into the ocean. Just raising and lowering it takes about an hour to sink down and another hour to bring it back up. So it's quite a process. But how do these floating dry docks get there? Well, they start off as sectional dry dock pieces, pontoons. The main body is the pontoon. This is the 28-foot high, basically barge. It's got 2 wing walls that are folded down in transit, so they don't resist the wind so much, make it more controllable. And they're both covered with materials, lumber and whatnot, that will be used during the operations. But interestingly enough, they put the control box, the little conning box up on top. They also put the machine guns up on top of the side of the wing walls for transit, along with the life rafts. When the wing wall goes up, those all get moved over to the top of the wing wall. Kind of a long, big process. But by the time you get 10 of these together, you can then turn it into a floating dry dock. So here we have the process of raising these. You can see the pontoons are just covered with stuff. They're jacking up the wing walls one by one. They have a mobile crane that can help move that stuff around. And once they get that done, they start welding the sections together. And each section, welded pairs, joins more pairs, and pretty soon you have 10 of them all lined up. Unfortunately, the first dry dock, ABSD-1, lost one section when it sank with 13 men on board during assembly. And it was assembled with 10 sections initially, and later 2 more sections were added to make a total of 10. So, excuse me, wow. Okay, so got to see some of this up in Portland, and they actually have these great big 500-ton jacks pushing away on a strut that jacks it up 1 foot at a time. And you rearrange things and put pins back in, back and forth, and jack it up 1 foot at a time until it's 55 feet in the air. And then you let it down gently onto the deck and secure it with 240 1-inch bolts. It's just huge. But how did we get here? Okay, who was this guy? Frederick R. Harris was a young engineer, Professional Corps of Navy Engineers in 1903. He died just before I was born, 1949, at the age of 74. But he was a genius when it came to naval facilities, docks, wharves, things like that. We found his work in the Encyclopedia Britannica, and that was kind of the entry point to finding out how this all happened. He was promoted from lieutenant commander to rear admiral at age of 41. So he skipped commander and captain because of his expertise with docks and salvaging work that had failed in Brooklyn and Hawaii. They had tried to build some docks, and they had collapsed during the building process when they tried to dewater them, and they had to be completely re-engineered and reconstructed. And Frederick Harris was the guy that did that as a young engineer. So he was chief of the Bureau of Yards and Docks in World War I for the US Navy, which is kind of a big deal, really big deal. So anyway, after World War I was over, about 10 years later, he formed his own company, Frederick R. Harris Engineering Incorporated, and designed floating dry docks for the Navy. Okay. So what we found in the Encyclopedia Britannica was his patents and the description of floating dry dock. And the key thing about the patent was the buoyancy chamber here, and that provided structural relief and some buoyancy where it was needed. These curved bottom here, and if you look at the yard floating dry docks that were built here, they're exactly this design. So they built 2 or 3 kinds here, maybe 3 or 4 kinds actually, but of the big kinds, this was number 1. And then he also patented the Advanced Base Sectional Dock concept here, which started off with the buoyancy chamber right here. Excuse me. Sorry about that. The key thing about the Advanced Base Sectional Dock was, what is it? Well, it turns out that inside, in this central buoyancy chamber, the key little thing is that this is where the crew ate and slept, and this is where the machinery was located. And on deck, you had a way to carry a floating crane with you, fold it down the wing walls, and assemble this where needed in the South Pacific, for instance. But this whole concept worked together really well, and so he got the contract to design them and provide those designs to the Navy, to the Bureau of Yards and Docks, which then got them built. Just getting over a cold, so sorry about that. So they were built all around America. New dry dock facilities were built to build these floating dry docks. Excuse me 1 second. I would swear it would not be this dry, this close to the coast. Sorry. So anyway, the initial 3 floating dry docks were for the battleship series. These were the large of the Advanced Base Sectional Docks, which is a model I have here. They were built in Pollock, Stockton, California, Everett Pacific up in Washington, Chicago Bridge in Morgan City, Chicago Bridge and Iron in Eureka, right here, and also Pacific Bridge and Pittsburgh, Des Moines, back in Pittsburgh. So a little map of the U.S. shows you about where those were built. We think, actually, Eureka may have built 8, 4 from the first series and 4 from the second series. I haven't quite got confirmation of that yet, but I am working on it. So a few adjustments. Mare Island probably didn't build 18, but it's really hard to tell exactly who built what, where. But there is some hope for some of that. I mentioned the first 3 were the large ones. The second 4 floating dry docks were slightly less capacity. They are called Advanced Base Cruiser Docks. And they were only 23 feet high instead of 28 feet high. They had some individual histories. ABSD 2 and 4 were damaged by a torpedo attack by a Japanese airplane that thought they were a The Japanese airplane thought they were an aircraft carrier. They look a little bit like an aircraft carrier. Not quite the same thing, though. One section I mentioned was sunk during assembly and lost with a crew of 13 men. But if you add them all up, over 155 docks were built during the war. A couple dozen were built right here. And half of those, approximately, were deployed around the world to advanced bases, mostly in the South Pacific. Some in Hawaii, and places like that. So another interesting tidbit from around here is that Paradise Cove, Tiburon, was where they did the training for the specialized crews for the floating dry docks. They trained a lot of divers and also dock operators. So inside, they're fairly conventional, but knowing all about stability and lift was a big deal, so they trained people to operate these safely. So Tiburon claimed about 4,000 people during the war. So what was interesting about the dock is not just a dock, it actually is a ship. Machinery deck, and below that a fuel tank. You have crew quarters, mess decks, and each section is self-contained in terms of machinery and pumping for flooding and lifting out the dock from the water. And the wing walls were configured for a variety of purposes, much like a ship. So we had captain's quarters, officer's mess, ship's office, medical dental, spare parts, machine shop. Everything on the technical level was pretty much on the top of the wing wall. So just to illustrate that a little bit, if you can. When you take the wing wall apart, it's ballast water on the side here, but above the safety deck, which is 14 feet below the top deck here, was where you had officers' quarters, machine shop, spare parts, paint locker, officers' quarters, dental, photo, radio room. All those things were distributed along the wing wall, all around the dock. So from there on down was all water, except for the central chamber inside. But the wing walls were essential. On top of the wing wall, you had the anti-aircraft guns, you had a crane, capstan. On the pontoon decks, you had the mooring cables, anchor, things like that. There's a lot going on here. And each one was a little bit different. So As I said, it's basically a fairly large ship, the equivalent of a cruiser or a battleship in terms of what it had. And the radio room was, of course, very busy. The ship's records and planning was very busy. You know, the spare parts you needed. Do you have enough welding rods, enough steel plate? All the stuff you needed to make your repairs, get these ships back into the fight. That was very important to have that on hand and make sure it's working. So, and of course, it has its own telephone and central ballast tank indicating system, so you can tell what is happening. They actually have a surveyor's sight along the side of the dry dock walls here, so you can tell if there's too much pumping or too little pumping in a certain section and adjust for that to keep the whole dock straight as you raise and sink and not cause too much stress on the ship you're trying to lift. Lots of things were thought out and done properly. And these things are huge. They're 206 feet long. Each one is 80 feet wide. And it's just a lot of structure inside. I'm kind of coming from the technology side, so all the stuff was interesting stuff for me. The wing walls are 20 feet wide by 80 feet long. So inside that wing wall, when you go to the full scale, that's a lot of space. Actually, a lot of space. About 3,500 tons per section. So about 35,000 tons for the whole floating dry dock. There are a total of 12 ballast tanks in each pontoon. The center space we talked about, the key element here where you have the dry space, is 36 feet wide and 36 feet long, 80 feet wide. And it's got engineering, mechanical, and the crew and fuel below that. So, not too much in the technical stuff here, but it is a big thing. It takes about an hour to pump out, the equivalent of about 6 acre-feet or 3 Olympic-sized swimming pools, and that's in each section, times 10 sections. So just for here we are on the home front, and you're building Liberty ships and all the other things you're needed. It turns out that a Liberty ship is about the same amount of material, the same amount of person power needed to put these together. They built 18 shipyards just for Liberty ships, and they built about 6 shipyards just for floating dry docks. So it's a huge effort, huge. The crew was a very diverse crew. They had course captain and officers to operate and manage the crew positions, engineering. You had, of course, like I said, a radio room, and didn't need a chart room per se, but you had radio room, offices, captain's quarters, all those things a regular ship would have. Dental office, medical office, first aid, things like that. Stuff could happen. And so about 500 people overall just assigned to each dock, plus more people on auxiliary ships tied up next to the dock to provide special things like foundries or pipe fitting or whatever else was needed that could provide more of the machining capabilities that the dry dock itself couldn't provide. And of course, we had the Tiburon, California training facility for the special ratings. So, but this was all interesting. Like, where did it all come from? Where is it? The big project here was to try to find out how to build a model, what the information we needed in order to build a model. And we contacted the National Archives and asked them, what do you have? And they go like, well, we have some blueprints. They're in a microfiche. Come and get it. Well, we had COVID, so that took about 3.5 years to resolve before they go like, okay, now we're open. So we went back, visited College Park, and go like, oh, there's the box. They actually found the box. Wow. Took a little bit of asking. Are you guys sure you can find that? Sure, I think we can find it. Actually, one person says, no, I have never seen it, and the other person goes like, I know where it is. So anyway, but the box had microfiche blueprints, and sure enough, it all says Frederick R. Harris, Consulting Engineers, New York. But inside those blueprints, everything we need to know about the machinery layout, the size and spacing and the structure of the floating dry dock pontoons, and it got interesting. we got enough information to build a model of one of these pontoons. So you can see that this one little pontoon here, you break that away. That's the pontoon model we built right there. Keel blocks and whatnot. On top of that sits a ship. And you have wing walls that can fold down, the whole thing. And hopefully we'll show you a little model of this, I think. This gives you an idea of just how big these are. So I've been on one of these, and I can tell you they are that big, if not bigger. So the model there, those men are about as tall as the keel blocks are, and they're much, much shorter than the side of that wing wall, which is 55 feet high. If you ever look at 55 feet from here to there, okay, that's not so bad. You go 55 feet up, that's different. All right. We're on the wrong presentation. But what happened was, we'll skip through this a little bit here. But we made a model of it, partitioned it off just the way it was in the blueprints and drawings, put all the pipes and fittings inside it. This picture comes from here. This is CB&I building a section of a floating dry dock, and you can see all the structure and bulkheads and stiffeners there are in there, and that's just one pontoon. There are thousands of pieces that go into one of those. We built a model of that, more model, and then we tried to break down the machinery deck into the generators, the motors, the pumps, the valves, everything else that went along in that machinery deck. And then above that, we had the crew quarters. Of course, we had the bunks. We had to make bunks. And the latrine, the head, the toilets, the sinks are all in there. And just a fun kind of thing, like, how did it all fit in there? Well, this is how they did it. So every third section, this deck was a galley deck. And so they had their baking and mixing and the wardroom, not the wardroom, but the crew mess, and all this stuff on one of these decks, on every third deck. So it got kind of carried away. And the captain's quarters had a ship's office next to the ship's office, next to the ship's records, along with the radio room, dentist's office. So everything for the control and command was right next to the captain. But how did we find out about who was built where? Well, it turns out they had a little plan, a whole big plan that said, okay, here's the assignment of sections here. Section number 17, built by Pollock Stockton. Section number 13, Pacific Bridge. What's in it is a bunk bed. What's it used for? Paint and oil storage or a machine shop. And they built this chart for each of these first three advanced base sectional docks. And then they went and built it. So that's how come Chicago Bridge and I in Eureka built 2 for ABSD1 and 2 sections for ABSD2. And then when it was all completed, you have all those parts to go together, and then they fall into place, and then you get ready for shipping them out. You put a crane on it, fold down the wing walls, and off you go. So can we take a short break here? Oh. Great. So are we all flying for a second? It's kind of fun, which gives you what they did with it, bulk general stores. It's a bunk pontoon. We had lumber storage up here, pilot house up here, the bow, we had skegs back here. So each individual section was specifically purposed to go together as part of a system. That's very, very important here. So all these guys all had the lineup and be put together properly. So, so actually, since ABSD-1 lost one of its sections during assembly, it wasn't until ABSD-3 came along they were able to borrow one section from it and use it to complete ABSD-1. So with the right section matching up. So let's try this. Let's try this.
Ooh.
Okay, so the audio, I'm sorry. Hang on one second. Yeah, is the audio better now?
Go ahead. I just have to turn it up on the projector.
Yep, okay. All right, let's go back to that. Well, that's going to be the slide. This is the stop and run.
Right.
Yeah.
Yeah.
Well, that's a still life.
Oh, here. How about this one?
That's what I was trying right there, yeah.
Yeah.
Let's try it.
Sometimes you just have to like.
Sometimes that's what you know. Sometimes you try the simple thing. Okay.
Wow.
Inside, the wing walls have all kinds of facilities. This is the ship's office, captain's cabin, captain's head. He's got his own restroom, shower. Captain's office, the ship's office with all their records, a ladder to the top of the wing wall, and a spiral staircase going down to the pontoon spaces inside. And down below, we have the ballast tanks, 12 of these, 6 on each side. When you come into the lower pontoon deck here, you come to the spiral staircase, a long 60-foot tunnel, and then you come into either crew quarters on 7 of these docks, or the mess deck on 3 of the docks. You have bunks, lockers, firefighting equipment, one quarter for officer, electrical transformers, ladders down below, watertight doors, and the bed for the domestic showers, toilets. And below that, then you have the operating part of the dock, which has tanks for fresh water. It has the 2 main pumps, which are 16,000 gallons per minute each, 200 horsepower motors, and electrically operated valves to control the flow of the water. You have 2 diesel generators, all of the equipment it takes to make that work. Mufflers, oil, heat exchanger, things like that. 2 electrical rooms, each with the generators, and switchboards and control panels, and a pump room, and a boiler room. Interesting little point down here is we have a ship's telephone booth right here, and multiple log stations for logging data, activities and events. But the telephone booth is sound protected, so you can hear what's going on in terms of opening and closing valves and operating Okay. So that was kind of a fun little interview. It's in the Press Democrat. It's available online. Just Google Benefield Werback and you'll come up with it. But anyway, so that was kind of a revelation getting the National Archives, doing the model. I built a second model because that model you just saw is now on the way to the South Pacific World War II Museum in Espiritu Santo, Vanuatu, which is where the first dock was operating, World War II. So this dock here and the model are both commercially available. They're to scale, like 1 to 350. Just to give you an idea, you know, a man on this is 1/8 of an inch high. That high, about. Wow. Okay, but then we gave this talk and going off, you know, sure enough, there's more. What more could there be? Well, Bill Turner, back here, used to live here, and his family actually worked for Chicago Bridge at one time. Dad was a electrician, and he managed to collect the pamphlet, the last issue of Minuteman, and he had that in his drawer for about 60 years, and finally said, oh, by the way, I should look in my drawer and give you this. Okay, and he did. And it has all kinds of happy stuff in here. Okay, what was built and when, who worked here a little bit, all about the women welder workforce, and how well they did, which was quite well. And here we are, the women welders workforce. Here we have Bill's dad's CB&I card, at least the front side of it. So all historical stuff is kind of cool.
I have to correct you. That's
oh, yes.
My brother.
Oh, it's your brother.
That's my brother, and he was fired the day afterwards for smoking on the ground.
So that's his mug.
That's a great picture of him.
That's his mugshot, but anyway. Yeah. Very good, your brother. Okay, thank you. Okay. So, but that whole home front story was the other reason we're here today. Things changed rapidly after December 7th. In January, CB&I is looking for suitable West Coast sites. That's like a couple weeks after Pearl Harbor. In February, they have selected a site. They have built a road. They have contracts. They are doing stuff. They're open in March. Yeah. Their welding school is in April. It's like month by month. In May, stuff is coming in, which means they have designs in hand. They're training people in assembly and reading blueprints and everything else you need to be able to do, hiring people by the hundreds. And in September, they get the blueprints for ABSD sections 5 and 6, the first two for this dry dock. In January, they deliver their first large floating dry dock, not one of these, but somewhat similar. And in June and 43 and to March of 44, they deliver the first 4 sections. And they built 4 more beyond that, as far as I can tell, of the smaller size that aren't quite as big. So in addition to building these 4 big sections, they built 6 auxiliary floating dry docks and 4 large yard floating dry docks and 6 crane barges. So they're quite busy here during the war. Just a typical place in America, right? 3,000 workers, and pretty much you had steady employment if you could find a place to live. So one of the persons listed in one of the stories in the latest version of Minuteman here was about James Hastings, fireman first class U.S. Navy from Eureka. Okay, young man from here, got in the Navy, worked at CB&I for a little while before the Navy, and then was assigned to an ABSD section at Eureka. Didn't stay with that forever, but was assigned to the 3rd dry dock of this series somewhere in the Pacific in 1944. And so we have some of his letters home in here that say, hey, by the way, you know, they're working us pretty hard. We don't get much time off. Normally we get to go ashore every 2 weeks for a little softball, but it's been like 2 months. So, but overall, he had a good experience, came back okay. So, but
I have a question.
Interesting, yeah.
Let me ask.
What was the biggest ship that these could accommodate? A cruiser?
So that's for your online audience. So.
Okay.
Go ahead.
The question is, the largest ship that these could accommodate would be a cruiser?
So the largest ship that the first 3 docks could accommodate was a 55,000-ton full-size Iowa-class battleship. So the full size. Even then they had to make sure they were kind of low on fuel and maybe take off some of the ammunition. But 55,000 tons was the biggest of the 4 Iowa-class ships that these docks were designed for. The normal cruisers, the 15,000-ton cruiser, could easily be handled in the second set of these large floating dry docks. So between those 7 that were in total built, all of those could handle the cruisers, but just the first 3 could handle the battleships, the new battleships. They could all handle the old battleships of the 35,000-ton variety, twice what a cruiser would be, or maybe even more than that. But otherwise, those battleships came back to Pearl Harbor or to the West Coast.
Thank you.
So, did that answer your question okay?
Yeah.
Okay, thank you. Okay, so he survived the war and came back okay, but a young man from Eureka. Yeah. So in communicating with the South Pacific World War II Museum, they provided some information, which was kind of cool because their whole purpose, one of their whole points is ABSD-1, this Advanced Base Sectional Dock, which was docked right off their museum's front window in the bay there. So they sent me an article by Captain Mac Angus, showed a cutaway diagram and described the operation of one section of the floating dry dock that was in use down there. So basically that was the big clue, and I had already had access to the National Archives and was building the model at that time when this information came around, which is kind of cool. There's very little information online. But this article from 1945 suddenly became available, and here's how it works. And this is all Frederick R. Harris and his engineering team all over it. The central buoyancy chamber, the tunnels, the equipment is all internal. Floating dry docks these days, the equipment's up on the safety deck above the high water line. In here, it's below water line, a long ways, 55 feet below. So, kind of cool. So what happened to all these things? Well, some were rumored to have been sunk off New Guinea and places like that, but that's actually not the case. That's actually a smaller dry dock, which you can see sort of underwater here, but an Advanced Base Sectional Dock is at least twice as big. If you go on the Google Maps and measure that, it's not a very big dock, but it is sunken down there. ABSD-7 is mostly in Brownsville, Texas. It supported nuclear submarines in Holy Loch, Scotland for 25 years or so, and then the oil industry bought it and moved it to Brownsville, Texas to make oil rigs. But wait, there's more. Oh, so I said. We tracked some of these down via the internet. A young man put together a fairly good list of where things are these days and who built them. Not quite complete, but anyway, we looked at that and go those look a lot like Advanced Base Sectional Dock sections, and indeed they are. So this was this is parts of ABSD-2 and ABSD-1 from Hawaii, and they purchased some sections for the Viger Dry Dock shipyard up in Swan Island, Portland, Oregon, and I met some fine people up there, and they gave me a tour. I would just like to point out that another name comes up here with ABSD-2. You all know who Commander Joe Rochefort was? Midway, right. Intelligence officer, cryptology, Japanese language linguist, smart guy. He got a little,
They didn't get along very
got a little
good with the G20 people in Washington.
Exactly, and that's a whole nother story. Admiral King and G20 and all those guys. So he was kind of pulled out of Hawaii after Midway, and he wanted a seagoing job, which he couldn't have because he knew so much. So they gave him a job down here at Novato with the ABSD-2 commissioning it before it went down to the South Pacific. So he's had some interesting jobs. But anyway, we got a little nice connection here, and we got to go visit this 80-year-old floating dry dock, of which 4 sections are operating. Very, very nicely built, I must say. Everything is straight, true, exact. The dockmaster said he could put a ship anywhere on it and it would take the load. It's in really great shape and was built very well. So this is a little over 300 feet long, and the wing walls are 55 feet high and 140 feet between them. That is a lot of space, by the way. Lots of space. Inside, the main part of the equipment is still original and operating. Check valves, the vertical vane pump, and the 200 horsepower motor are in there and operating, and they have changed all the wiring to be operated by one person instead of a whole crew. So one person can flip a switch and the whole thing starts clicking away. Very, very cool. But you go around inside the machinery deck section here, and they had some really nice equipment in there. 7-cylinder Ingersoll-Rand diesel engines, all of the cooling and oiling and everything else to make those things work. And everything was basically really first rate as far as I could tell. All installed nicely and, as far as I know, operated properly during the war, which is kind of essential. Today, where this Advanced Base Sectional Dock was, Espiritu Santo, looks a little bit like that from the front porch of the South Pacific World War II Museum. And the dock was right up there, right at the edge of the blue water, where it could sink down 80 feet and take any ship you could run its way in World War II. So this has really been kind of a fun story. It turns out our daughter was with the Army Corps of Engineers, and one of her dredging ships that's used in the Columbia River was being serviced by the Vigor Dry Dock in Portland. And so, gee, Lieutenant Colonel, can we get a view on that? She goes, I'll ask. And she comes back with, yes, when would you like to go? So we did this presentation up there, and they took us around, and top to bottom, you know, we have dozens of pictures from the inside. It's pretty much stripped inside except for the operating needs of the pumps and the valves. But it's in pretty good shape. One of these is also in Croatia, operating off the coast there. A few more sections are still in Pearl Harbor. And let's see, parts of ABSD-4 are in the ports of Vancouver and Portland. So they're used for loading and unloading cars as pontoons. So the second set of floating dry docks, what we call the Advanced Base Cruiser Dock, ABCD, they were not as high, but a little bit shorter, stubbier, but 20 feet wider. So going from 80 feet wide to 100 feet wide, it took fewer sections. They couldn't lift as much, but they were more appropriate for cruisers and large transport ships and anything else, tankers that might need to be docked during their time in the South Pacific. But a huge story, taking these down there, bringing them back, you know, trying to track down where they are and how they got there, or where they went and are they still there. And, you know, the men who worked on these things and the men and women who built them, they're still there. That's incredible, right? So, any questions?
Oh, what?
Yes.
Has there been or will there be a book written about this dry dock business?
Well, there are books written about it. There are no books I'm aware of about the Advanced Base Sectional Docks. There are a bunch of online articles about the Navy's bases in World War II. Yeah. But I just got a call from a guy from Poland who went to Croatia and gave me pictures of this one big remaining dock all by itself, and he says he is working on a book.
Oh, great.
How about that? So we are communicating on exactly how they worked and where they were built and how many were built. Well, we think that each of these was 10 sections, was supposed to be, and the following 4 docks were each 7 sections. If you multiply that out, we think there were 58 actually built of these sections. And these are very, very special sections, right? They have everything in them needed to operate as part of a floating dry dock. The other dry docks were also self-contained. Some were shaped like ship hulls so they could be moved around a little bit, but they were designed for, things like destroyers, small cruisers, patrol craft, usually much, much smaller ships. These are the only ones that could take the Iowa-class battleship, the 55,000-ton battleship that we had late in World War II. We built 4 of them, the Iowa, Missouri, Wisconsin, and New Jersey, right? 4. They actually did not need to go into these floating dry docks. By the time they got into the war, the big threat was kamikaze, and they were able to defend themselves pretty well enough. They never needed to be dry docked, to be repaired under emergency conditions. But a lot of other battleships, mainly a lot of the ones that were repaired and got brought back to service from Pearl Harbor, those that did get hit could go into these dry docks no problem. That's how the California got there, for instance. So it's a whole quite big story, the whole logistics thing, dry docks, food, fuel, men, it's a big process. A lot of paperwork, a lot of telephone calls, a lot of plans, a lot of meetings, but this is just part of what was done, right, during the war. And some of it happened right here. Question?
Can I pass this to you?
We'll pass this microphone back to you.
So from what I've heard,
One second.
from your pictures, and what I've heard, it sounds like here in Eureka, a number of sections were built,
Yes.
or also call them pontoons, right?
Yes. Yeah.
Separate pontoons, a number of sections were built that would go together for the bigger dry docks, right?
Yes.
And then also, in addition to that, there were probably some other smaller, self-contained dry docks built here?
Yes, if I can, I think I have a slide about that. Maybe I don't. Sorry, but yes, they built yard, floating dry docks, which were single section, and they built the floating dry dock crane barges and other things. Far more of those. I believe they actually built 8 sections here, 4 from the first set of 3 docks and 4 from the second set, the cruiser size docks, in addition to the yard floating docks and auxiliary floating dry docks that were shipped out from here. Probably about 30 or so total sections and floating dry docks complete. So it was a big effort. So yeah, 25 or 30, I think, about. So it's hard to tell from the available records. The numbers change a little bit, and it's just hard to tell, is this really this or that? Another question?
2 questions.
Yeah.
First, what was the source of fresh water for the men on board, and what was their source of heat? What kind of heat did the captain have in his quarters and so on?
So my understanding is I don't have a manual of operating for the floating dry docks, but the source of water was an evaporator. So basically what you had on a ship, they used a very similar thing. They would use hot water and a low pressure system to evaporate and create fresh water that way. They would run that 24 hours a day and store the water up as needed. So they had hot running showers and hot water for cooking and whatnot. So they had their own freshwater supply equipment on board. The bottom of the ship was filled with diesel fuel, like 44,000 gallons. So they would run quite a long time on one load of diesel before it needed to be refueled there. So they would be self-sustaining in that respect, their own power, their own water. For heat, not that they really needed a lot, but they had steam heat available from the excess of the water purification and the heat exchangers with the diesel engines. So they had heating and ventilation, but no air conditioning. So, but going to work on one of these things, they did have deck hatches. When the dock was out of water, there were watertight hatches, a couple of them on deck that they can go down just to some stairs into the quarters. If they were flooded down to let a ship in or out, course, the only access was from the 55 feet all the way down to the bottom of the tunnel to get across underneath the deck there. So access was kind of a lot of interesting thing. You probably didn't go up and down unless you really needed to. And there's plenty of work for everybody here, I think. Just getting to work was kind of a big deal. Yeah.
Oh, yeah. What held the sections together? You know, you had to coordinate the ballasting, but it seems like there would have to be a mechanical connection between the sections.
So you notice that each section has this hinge, and the wing walls could fold down. Okay. These pontoons were what was called self-docking. So when the wing walls were up, was when they were welded together. They welded a pair of splice plates on the outside, up and lower, and on the inside of each wing wall. And these were huge. They're like 3-inch thick by 15 feet long by 2 feet high splice plates. They're huge pieces of steel joining the two wing walls, top and bottom, inside and out. So that's what made the dock rigid, was these huge connecting steel plates welded in. When you wanted to move the floating dry dock to somewhere else, you had to cut that stuff off and go do it again. It was a big deal. So that's what made the dock stiff. So in fact, when the docks were damaged by the Japanese torpedo plane, ABSD 2 and 4, they unhinged the pontoon, flooded it down to release it from the wing wall, floated it out, flooded down the dock itself 25 or so feet, brought the damaged pontoon in, pumped it all out, repaired the pontoon, and put it back. It was like, huh, okay, well, you can do that if you really try, but it's a lot of work, lots of work. You'd rather not have to do that. Anyway, so great, good questions, yeah. Well, there's a lot of you know, interesting how all these things work together, you know, and finding these around the world, and you know, what are they doing now? They're actually just still doing useful work.
Great.
Great.
I think one of the most remarkable things I've learned from you is that it appears that CB&I here in Eureka never built a complete dock. It was always sections, and when it got to where it was going, the sections that came together could come from several different yards, including Eureka.
They were built to incredibly tight tolerances. Incredibly tight tolerances. That when they specified 11 and 13/16, they meant 11 and 13/16. You know, everything was square, straight, ship shape. The picture of the dock just going straight down, that's the way it was built. Though they were interchangeable.
Yes.
They were. Yeah. They really were. Yeah.
So that the first dock section that was lost off the Golden Gate, that's all it was one section, because I always felt that was the whole dock, so this is great correction.
In that case, I think that was the whole dock.
Oh, was a whole
I think that was
one of the
yeah.
smaller ones?
It was one of the smaller, it'd still be a big dock, but one of the smaller ones.
I
Yeah,
see.
yeah,
Good to know.
yeah.
Thank you.
These weren't that big until they got assembled.
One final question. Had you ever had an opportunity to meet Leroy Marsh here in Eureka?
No, no.
He had a file of what happened to every last section that was built, at least out of Eureka.
Yeah.
And I think his widow is still in the area, and I think you should have his files.
Well, I'd love to look at them for sure.
It was remarkable
Yeah.
what he was able to find out, which docks were still in use or where they went to begin with. I'll see if I can get that out of the phone book before I go.
Okay, thank you. I do have one piece of paper from the U.S. Navy for the docks that were brought back to Portland. They have a material tracking thing that says, you know, what the number was and not where it was built, but, you know, where it came from in the Navy system and what it was, you know, the year it was built, things like that. There's information out there, but it's really hard to find. So something like that would be very helpful. Because I think we built 8 sections here, not just the 4 that I have. Well, there's 4 plus 4, but it's really hard to tell. Some places say Mare Island built a dozen of these, but Mare Island didn't build them. Mare Island built other things, but not these. Anyway, so great, good. A lot of good information out there. Just have to know the right person. Okay, well, another question?
This is probably a ridiculous question.
Hold on, can I get you to speak into the microphone?
Thank you.
I've been sitting here thinking about the flotation that they have recently installed to provide food for the Gaza.
Yeah.
I mean, this seems to have been so successful.
So the Navy now has what their portable, they already had those sections built and ready to go for emergency logistics. And they installed it over on the Mediterranean coast of Gaza. I believe that mostly came from Italy or places like that.
Okay, but it wasn't very successful, though, was it?
Well, it's sort of like our beaches in Normandy. You know, we did the gooseberries and the mulberries there. But those storms can really kick up a lot of water, and something floating but not able to move can really be beaten up quickly. So it's really hard to secure something that floats and has to move a little bit with the tides and things like that. So it's really a tough job to make anything secure when the ocean gets going. I mean, you've probably seen it here quite a bit. But yeah, no, they're trying. They're trying.
Thank you.
Okay, thank you. All right, well, it's been a fun trip. This has been like 5 years, and you know, my daughter knows the guy who knows the guy. Oh, that's pretty cool. So, but the National Archives had essential stuff. The South Pacific World War II Museum has a model, which we hope they'll be able to put out for display before too long. They had to build a whole new building for it. Just kidding. But it's quite a story. You know, people lived on these, worked on these, and took care of things as needed. So, you know, we're working tonight, right? Okay, get it done.
Thank you, Ann.
Okay. You're welcome.
Thank you so much. Thank you.
Thank you.